Assalamu alaikum, respected teacher and my fellow students. First of all, a warm welcome to all. The topic which I am going to discuss today is unit number 3 variation, exercise 3.7, question number 1 and 2. So without any wastage of time, let's proceed. So question number 1 is the surface area A of a cube varies directly as the square of length L of an edge, and A is equal to 27 square units when L is equal to 3 units. Find A when L is equal to 4 units and L when A is equal to 12 units. So first we have to understand the question. Here they are telling that surface area A varies directly to the square of length L, which means A varies directly to L square. Given that A is directly proportional to L square, to remove the variation sign, we will put variation constant, which is K. So A is equal to KL square, which will be named as equation 1. Before finding the value of A and L, we have to find the value of K. So put the value of A is equal to 27 and L is equal to 3 in equation 1 to find the value of K. 27 is equal to K into 3 raised to power 2. 27 is equal to 9k. 9 will be shifted to left hand side. 9 ones are 9 and 9 threes are 27. So the value of k will be 3. Now put the value of a in equation. Put the value of k in equation 1 to form equation 2. A is equal to 3l square. This equation will be named as equation 2. According to first part of question, we have to find A when L is equal to 4 units. So we have to put the value of L, which is equal to 4, in equation 2 to find the value of A. A is equal to 3 into 4 raised to power 2. 3 into A is equal to 3 into 16. 16 multiplied by 3 is equal to 48. So the value of A will be 48. According to second part of question, we have to find the value of L when value of A is equal to 12. So put value of A is equal to 12 in equation 2. 12 is equal to 3L square. Here 3 is multiplied. When shifted to left hand side, it will be divided. So L square is equal to 12 divided by 3. 3 ones are 3 and 3 fours are 12. L square is equal to 4. To remove the square of L, we will take square root on both sides. In result, the value of L will be equal to 2. Now proceeding to question number 2. The surface area S of the sphere varies directly as the square of radius r, and S is equal to 16 pi when r is equal to 2. Find r when S is equal to 36 pi. Again we have to understand the question first. Surface area S varies directly to the square of radius r, which means S varies directly to r square. Given that S is directly proportional to r square, again we will remove the variation sign and put the variation constant. So S is equal to k r square, which will be named as equation 1. Before finding the value of r, we have to find the value of k. According to question, S is equal to 16 pi and R is equal to 2. So put the value of S and R in equation 1 to find K. 16 pi is equal to K into 2 raised to power 2. 16 pi is equal to 4k. 4 will be shifted to left hand side. 4 ones are 4s and 4 fours are 16. So the value of k will be 4 pi. Now we have to put the value of k in equation 1 to form equation 2. S is equal to 4 pi r square, 4 pi into r square. This equation will be named as equation 2. According to question, we have to find the value of r when value of s is equal to 36 pi. So we have to put the value of s, which is 36 pi, in equation 2 to find the value of r. 36 pi is equal to 4 pi into r square. Again 4 will be shifted to left hand side as 4 was multiplied at right hand side, so it will be divided at left hand side. 4 ones are 4 and 4 nines are 36. Pi will be cancelled with pi. R square is equal to 9. We have to remove the square of r, so we will take square root on both sides. In result, the value of r will be 3. Hope so you all understood the lecture.
Very well done. I liked a lot your presentation. Abdullah Kamran, very well done. It was very nice. Everything was managed very well. The concept, the explanation, the voice clarity, and means the concept, everything was very, very well. Keep it up. Okay, one question I have here from you means including Abdullah Kamran, you have to answer me that there when we take square root, mostly I told you that when we take the square root, so the square root will result in plus minus. But in these, when you have taken square root of L and you have taken the square root of radius R, but we have you haven't put the plus minus sign. Can anyone tell me the reason behind that why we haven't put plus minus sign there? Because in quadratic equations we used to write plus and minus both of them. So please, I want your answers. You can unmute yourself for giving the answers. If the question is not clear, then you can, okay, I have a answer from someone, but I'm not sharing it with you. I want some more answers, then we will go. I need some more answers. If no more answers, so let's go with someone, please. If you can turn on your mic and you can just give the answers to all the students.
Ma'am, it is because some quantities simply can't be in negative value. For example, radius and distance. So we can't write minus with them.
Excellent answer. As we know that in quadratic equations, when we do so, there it's not mentioned that the variable or the unknown quantity is belonging with what. But here in word problems, we can see that it is clearly mentioned there that L stands for length and R stands for radius. As we know that radius or length cannot be measured in negative. Like if you want to measure your length, so it can never be negative. So therefore, we don't write plus and minus sign. So we have to be sensible that where we have to put plus minus sign, we are not, okay? Fine. So if it's clear, so please, I want now Saman Khalid to share the screen for the rest questions. For presentation, please, now you have to be attentive. Saman, the voice is not audible. Please turn on the original sound.
Am I not audible? Is this presentation not audible?
Yeah, means there is no voice in it.
No voice?
No.
Okay.
If it is no voice, so you can go with live presentation, fine?
Maybe if I unmute myself, you'll hear it. Let me
No.
try it, and if it
There
doesn't
is
work out, I'll explain it right
okay.
now.
There is more options. You can go with original sound.
Original sound, where is it, ma'am?
It's on where you share your screen. There is a more option you can have from there.
Mm-hmm.
Fine. There is written computer original sound, so you can go from there.
Share computer sound?
Yes, exactly.
Okay, let me know if you can hear me.
Okay.
And if you can't, then I'll do something else.
That is
Okay.
very fine.
I'm going to play it.
Okay.
Assalamualaikum everyone, my name is Suman Khalid and
You
today
are audible
I'm
now.
giving
That
a
is fine.
mathematics presentation for chapter number 3, that is ratio and proportion. So in this presentation I'm going to explain question number 3, 4, 5 and 6 from exercise 3.7. Now before we move on, I want you to take note of the 3 fundamental concepts that we are going to use throughout the course of all these questions. The first one is direct and inverse relationship. Then we have the constant of variation or the constant of proportionality, that is K. And lastly, we have joint variation. Since we have already studied all these concepts in detail, I'm going to dive right into question number 3. Question number 3 states that in Hooke's law, force applied to stretch a spring varies directly with the elongation. So basically, F is directly proportional to S. The greater your force, the larger your stretch is going to be. As you can see over here, F is directly proportional to S. Now in order to eliminate the sign of proportionality and equalize both the sides of the equation, we have to use K, that is the constant of variation. Over here, we have established our first equation, that is F is equal to K into S. This is the most important part of the question because we are going to use it to solve the other parts as well. Now we are going to put the values of F and S in equation number 1 since we already have these values in the question. So putting F is equal to 32 and S is equal to 1.6 in equation number 1, we get 32 is equal to K into 1.6. Shifting 1.6 to that side of the equation, we get 20. So the value of K is 20. Remember that this value is going to remain constant. It is going to remain the same throughout the entirety of the question because this is a constant value. And now we are going to put the value of K, that is 20, in equation number 1 again. So over here we have F is equal to Ks, the value of K is 20, so we have F is equal to 20S. Now you can also use the value of K directly when it comes to solving the questions, but for the sake of brevity and convenience, we are establishing another equation here. So we have F is equal to 20S. This is equation number 2. So we have two equations here, equation number 1, and putting the value of K in equation number 1, we get another equation that we call as equation number 2. So now we are going to solve a real question. Put the value of F in equation number 2. This is equation number 2. So the value of F is actually 50. I'm sorry, I've written 5 over here mistakenly. Please spare that. But it is 50 actually, not 5. So please correct that. So putting the value of F, that is equal to 50, in equation number 2, we get 50, it's 50 over here, is equal to 20 into S. Now 50 divided by 20, because we are going to shift 20 to that side of the equation, is equal to 2.5. 50 divided by 20 is equal to 2.5, and this is our final answer. This is the value of S. S is equal to 2.5 when F is equal to 50. Moving on to the second and the last part of our question. This is essentially the same as the first part except that we have just reversed the places of F and S. So in this part we have to find F, and we do know the value of S and K. S is equal to 0.8 and K is equal to 20. We are going to put both of these values over here. 20 into 0.8 is equal to 16. So the value of F is 16. This is our answer set. This is our solution. S is equal to 2.5 and F is equal to 16. So over here we have concluded question number 3. And now jumping on to question number 4. So there are two things that I want you to take into account before solving question number 4. The first one is that this question implies the inverse relationship or the inverse proportion instead of direct proportion. And the second one is that the intensity of light from a source, this is the first value, varies inversely with the square of distance from it. Not just the distance, not just a linear distance, but the square of it. So make sure that you do square the distance before solving the question, or else you would end up getting the wrong answer. So as you can see over here, intensity of light is inversely proportional to the square of the distance. This is how inverse relationship is represented in mathematics. We are going to use the constant of variation I is equal to k upon d squared. So this is our equation number 1. Now putting the value of I is 20 over here, and d, the value of distance or d, is 12 feet. So putting the value of I is equal to 20 and d is equal to 12 in equation number 1, this is our equation number 1, we get 20 is equal to k upon 12 square. So squaring 12 we get 144. We have to multiply 144 with 20 and moving it to the other side of the equation we get this value. So this is actually a very large value. It is 2880. So the value of k is 2880. Now that we do have the value of our constant expression, we are going to put it in equation number 1. We are going to put it in this equation. So putting it in equation number 1, we get I is equal to the value of k, that is 2880 upon d square. So over here both of these variables, both of these values are unknown, and we are going to point it out as we get I is equal to the value of k, that is 2880 upon d square. So over here both of these variables, both of these values are unknown, and we are going to point it out as equation number 2. So this is our second equation. Now putting the value of d in equation number 2 we get. So this is our main objective, this is our question. We have the value of d, it was present in the question already, and we have to find the value of I. So we have both k over here, 2880, and we also have the value of d, that is 8. So now we are going to square it. 8 square is equal to 64. This value divided by 64, we get 45. This is our final answer. The intensity of light has to be 45 if the distance is 8 feet. This is how we are going to calculate the value of I. Okay, now we have question number 5. I hope you're following me. Question number 5 says that the pressure of a fluid, P here actually stands for pressure, the pressure of a fluid varies directly as the D. So over here we have the direct relationship again. So P is directly proportional to the depth or D. This is the first part. And if P exerted on the tank by a column of a fluid 5 feet high is 2.25. Okay, so the first thing that I want you to know, P is directly proportional to D. P, as you can see over here, is directly proportional to D. Of course, we are going to use K. P is equal to K into D. This is equation number 1. And now, referring back to the second part of the question, the value of P is 2.5. And the value of D or depth is 5. Right? So we are going to put both these values in equation number 1. P is equal to 2.25 and D is equal to 5. K into 5. Of course, dividing 2.25 with 5, the answer is 0.45. So by dividing both of these values, we get the value of our K or our constant expression. So this is 0.45. Now putting the value of K, that is 0.45, and the value of P in equation number 1. Okay, in this question I have not made another equation just because I wanted you to understand the other ways that we can use to solve this question as well. So we have the value of K, that is our constant, and we also have the value of P. The only thing that we need to do is use arithmetical operations in order to find the third value, that is D. So putting the value of P, 9, is equal to K, 0.45 into D. We're going to move 0.45 to that side of the equation. 9 divided by this decimal value over here, 0.45, 20 feet. So 20 feet is actually our answer. The depth has to be 20 feet if the pressure is 9. Okay. So the labor cost varies jointly as the number of workers, n. So the number of workers is denoted by n, and the average number of days, that is represented by d. So this value over here varies directly with two other quantities, the number of workers and the average number of days. So C is directly proportional to n and d, both of these values. This is joint variation. Now, of course, C is equal to K, N, and D. This is our equation. And now we are going to put the values of N, that is 800. So we have 800 workers over here. And we are also going to use the value of D, that is 13. We have 800 workers, we have 13 days, and lastly we also have the cost. So the cost is equal to 2,86,000. We have all these three values. We are going to put them in equation number 1. This is equation number 1. C is equal to this value, then we have K, N is equal to 800, and D is equal to 13. Multiplying these quantities, we get 10,400. Dividing this value with this quantity over here, we get 55.2. Now we know that 55 is not divisible by 2, so we are going to let it stay as it is. So the value of our constant is 55.2. And now we are going to put the value of K, that is 55/2, in equation number 1. So putting it in equation number 1, we get C is equal to 55/2 and D. This is equation number 2. So over here we have made another equation again because this question was sort of twisted. And now we are going to put the value of N, that is 600, and the value of D, that is 18, in equation number 2. This is our equation number 2. The value of N is 600 and the value of D is 18. We have to find the value of C. We have to find the cost of the labor workers. You can cancel 2 with 18 or 600 because these values are very large. And now dividing and multiplying all these values, we get our answer, we get our solution, that is 2,97,000. So the cost has to be 2,97,000.
Ma'am, done.
I'm very happy with the presentation. It's very nicely explained, Saman. Keep it up. Even you guys better explain than me. I really like your presentation, the way of explanation, the way the questions are attempted. That is very, very nice. This is a source of encouragement for the other students. So now we have Zahur Ahmed here for sharing the screen. There was a misconfusion and misunderstanding. He has prepared the presentation of exercise 3.4. So let's have a revision of 3.4 by Zahur Ahmed then. 3.7, some questions are left, so you can do that in homework, fine? These all parts are similar. So Zahur Ahmed, please, we want your presentation now.
Ma'am, tomorrow I will also explain the question number 6, 7, 8, and 9 of 3.7.
That will be much better, and that is very fine. Okay, just today share the presentation, then tomorrow we will go with that as well, okay? Very fine. Yes, there is no voice. Please share the computer original sound. Students, for questions, then you must have your questions with you if you have any, okay?
Simplify a large or complex equation. By applying Coppola and dividendo theorem, that the change this becomes in the equation is that plus and minus a bit change that come in this question. So the plus and minus change in come, and here also 2 plus 1 and 2 minus 2, 2 minus 1 will come. So then afterwards we will open the bracket. By opening the bracket, the outside sign will multiply with whole of the bracket, like plus will come, plus minus minus will come, and minus plus minus will come, and minus minus plus will come. So after then then also the terms which can be cutted, so cut it, and like this term can cut with this, so we have cutted it, and this term with this. So after then words we will the same terms, the like terms that can be added, we will add it, like it is come to like these two are two times, so we will write 2 square root x square plus 2, and here same like we are present 2 times 2 x square plus minus so minus 2. So here will also 3 over 2 plus 1 is equal to 3, and 2 minus 1 is equal to 1. So after then words we will cut 2 with 2, so this simply equation will come to us. So after then words, for further simplification, we will take square root. By taking square root of it, the square root on the values will cut, and the square root of the 3 is 9. So after then words, we will shift this x square plus minus 2 to the to the other side of this equal, and it will get multiplied with the 9. By multiplying it with 9, this will come 9x square plus minus 18. So now we will shift this x square because this value is bigger and this is smaller, so it's shift the smaller value to the bigger side, the bigger value side, and subtract it from the 9x square. So 9, by subtracting it from 9x square, 8x square will come, and by we will at the same time we will shift minus 18 to the other side of the is equal. So 18 plus 20 will 18 plus 2 will come 20. So then afterwards we will shift this 8 is multiplying with x, so we will shift it to that to another side of the is equal, and it will get divided with the it will get divided with it will get divided with the 20, so it will come to 4 to the 8, and 4 5 the 20, to 5 upon 20 will come, and we will again take square, because we want a simple x value, not x square value. So by taking square root, then x will come x value will come plus minus square root 5 upon 2. So coming towards the second question, question number 8. Question number 8 is like same like question number 7. Question number 8, like only that values is definitely change. Here is the change like 1 upon 3 is came. So also coming towards this solution, like firstly we will take componendo and dividendo theorem, apply on it. So like their sign will change simply. Firstly their sign will change, like here will also sign change. Then afterwards we will open the bracket and multiply the sign outside of the bracket with all of the value, like plus 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 minus plus plus minus plus minus minus plus minus. So here can be, then we will also again do cutting, like this value will be cutted with this, and this value will be cutted with this one. So then after when the like terms that are values that are remained, so we will add it, like these are present 2 times 2 square root x square plus 8 p square. Then afterwards we will also add these, so it is in minus sign, minus 2 square root x square minus p square. In this on this side 3 plus 1 is equal to 4, and 1 minus 3 is equal to minus 2. We will also cut it, like 2 ones are 2, 2 twos are 4. This minus sign will put it with the 2, so minus 2 will come. So afterwards then these 2's these 2 and 2 can also be cutted, so we will cut it, and this minus sign will be cutted with this. So the here term come simply term. Then we will for further simplification we will apply the square as a square root. Mm, Square root will apply on it, so like these square root inside on the values will cut, and 2 square root is 4, so 4 will come to us. Then we will shift this x square minus p square to that side, and multiplied with 4, so 4x square 4 minus 4p square, and the other value is here x square plus 8 p square. So then for we will shift this x square to the that side, because 4x square is greater than x, so we will shift to that side, and here it will be subtracted for 4x square, and 3x square will come, and for minus 4p square will shift it to that side of the is equal. And for 8p square and plus 4p square will come 12p square. Then we will shift this 3p to that side, and will get divided with 12p square. 3 ones are 3, 3 3 fours are 12. And so to find the value of the x, we will apply again square root. So x will come to us, square root of x will cut it, and the square root of 4 is 2, and p will also. So simply the answer of the 8th question is solutions.
Zahur Ahmed, sorry for winding up your presentation so directly without asking you. It was really a nice presentation, and I think this revision you have found it very means useful for you. Just the last part was also similar to that, so therefore I stopped the screen sharing. Students, if you have any question regarding these presentations, so you can ask, please. As we are running out of time, and less than 1 minute we have. So please, you can ask your questions. Okay, no questions. That is very fine. By Friday in the next class, I want you to keep your means rough registers and book ready with you, as we have to